Hello everybody, welcome back. Today we are going to be talking about continuous functions. There are two ways to talk about continuous functions. We can talk about whether they are continuous at a point, and we can talk about if they are continuous everywhere. This is a fairly straightforward concept, so hopefully this video will be nice and short. So what does it mean to be continuous? A function is continuous at a point A if the limit as x approaches a for our function exists, and that limit is equal to the function when it is evaluated at a. This sounds a little complicated, but just remember that the limit from the previous video is if you approach from the left and you approach from the right, it needs to be coming close to the same value. If it does not happen, limit doesn't exist, it can't be continuous at that point. But whatever the value comes out to, we want our function to be equal to that at that point. Which means if our function is not defined at a point A, well, we don't have f of a, so our function can't be continuous at that point. So, for a function to be continuous on its domain, it needs to be continuous for each point in its domain. So if the function is discontinuous outside its domain, it doesn't matter. So if we're looking at certain functions, they could be discontinuous, but as long as those discontinuities are outside of its domain, it does not matter. So let's take a look at this function here. Well, we can see that it's continuous everywhere except 2. A nice way you can tell if something is continuous just by looking at it is if it is possible to draw it without picking up your pencil or pen. If you are capable of doing that throughout its entire domain, it is continuous. This one, we have the discontinuity at 2 because you can draw it down to 2, but then you have to pick it up to start up at the top again. So, the reason why this is discontinuous at 2 is because we can see that the limit from the left is different than the limit from the right. Therefore, the limit does not exist. So that means it cannot be continuous at 2. But if our function wasn't actually defined at 2, so if we had an open circle down here, and we had an open circle up here, well, that means our function would not be defined at the value 2, which means it's not inside of our domain, which means outside of that, our function would be continuous everywhere, which means it would be continuous on its domain. So always keep in mind there's a difference between continuous on its domain and continuous on the entire real number system. Let's take a look at exercise. So consider the function f of x equals 1 over x. I want you to find where it is continuous and if it has any points of discontinuity. All right, so pause the video. All right, hopefully you've tried that out, and I'm hoping they found that the limit exists everywhere except at x equals 0. All right, because if we take a look at our graph, let's turn this on. Let's clear this old one. 1 divided by x. What's our window? Let's change this back to the standard. All right, that looks good. Let's graph it. You can see that it doesn't want that. Now, if you notice, we still have that point on there. That's probably because we still have our stat plots on. So go to second stat plot. Yes, we still have that on. So let's turn it off. Now we can go back to our graph. So we see that on the left, we're going down. On the right, we're going up. Which means my limit does not exist here. But is x equals 0 in our domain? Well, we can't put 1 divided by 0. Doesn't work. Which means it's not inside of our domain. Therefore, f of x is continuous on its domain. And that's actually it for this video. We will be talking about this more in class. See you there.